Okay, we're going to go through and just work through some examples. First example, x double prime plus 4x prime plus 4x equals 2t squared. First step, do the homogeneous. So in this case, for the homogeneous equation, we have something that looks like this. It's constant coefficient, it's linear, second order, so we assume general exponential function. We're going to plug that into the equation, so we have to take two derivatives. First derivative is the function times n. Second derivative is the function times n squared. Plug it in, so be careful, these are the homogeneous solutions. X double prime is re to the nt times n squared plus 4 times x prime is 4 times e to the nt times n plus 4 times x is 4 times 4r to the nt equals 0. Every term has this exponential function, so I can factor that out, and I know I do not want that to be 0 because that is my homogeneous solution. So I'm left with n squared plus 4n plus 4, which means that n squared plus 4n plus 4 is 0. And I notice I can factor that. So I have a repeated root of minus 2. So my homogeneous solution is r1 e to the minus 2t plus r2t e to the minus 2t. And I need that t because it's a double root. Now I'm going to focus on the particular solution, and I'm ignoring the homogeneous for a second. So for my particular solution, I've got my differential equation, and I'm keeping the non-homogeneous term in. So I'm going to go in two steps. First step is ask what's going on with this equation, and I notice it's polynomial of degree 2. You really don't care what it is specifically just yet. So I'm looking for a function so that when I take the function and its derivatives and add them up, I'm going to get a polynomial of degree 2. So I think that a polynomial of degree 2 is going to handle that, because this would be a polynomial of degree 2, this would be a polynomial of degree 1, and this would end up being a constant. And I don't really know which polynomial of degree 2 it is. So I'm going to guess it's going to be c2 times t squared plus c1 times 2 plus c0, where each of these c's is a constant. I don't know what they're going to be, so I'm going to take it and plug it into my equation and ask, what does that imply? So I'm going to need to take the first derivative. So derivative of t squared is 2t, derivative of c1t is c1, and derivative of c0 is 0, because again, these c's are constants. And now my second derivative, if I take the derivative of t, I get 1. So this is going to be c2 times 2. Derivative of c1 is 0. I'm going to take that and plug it back into the equation. So xp double prime is 2c2 plus 4 times xp prime. So that's going to be c2 times 2t plus c1 plus 4 times xp, and xp is c2t squared plus c1t plus c naught, and I know from my original equation that it has to be 2t squared. So what I'm going to do is I'm going to basically expand all this out, and I want the polynomial on the left equal the polynomial on the right. So let's rewrite that. So our differential equation was x double prime plus 4x prime plus 4x is 2t squared. My homogeneous solution is r1 e to the minus 2t plus r2t e to the minus 2t. I guessed a particular solution that looked like some kind of, that should be 1, some kind of second order polynomial. I plugged it in and I got 2c2 plus 4 times 2c2t plus c1 plus 4 times C2t squared plus C1t plus C0 is 2t squared, and that comes from that right-hand term. I expand everything out, so I multiply the 4 through. 4 times 2 is 8, then 4 times C1 plus 4 times C2t squared plus 4C1t plus 4C0 is 2t squared. So I'm going to collect terms. Notice I only have the one t squared term. For my t terms, I got something times t, so I've got 8c2 plus 4c1 times t. That's my only t terms. And then finally, for the constant terms, I've got 2c2 plus 4c1 plus 4c0 is 2t squared. Okay, so now how can this polynomial be equal to that polynomial? Let me rewrite this. So I have 4c2t squared plus 8c2t plus 4c1t plus the constant term, which comes out to be 2c2 plus 4c1 plus 4c0. That is equal to 2t squared. But notice this is also, I can write it as 0 times t plus 0. So I've got t squared, 0t plus 0. If this polynomial is equal to this polynomial, that means the t squared terms have to be the same. Also, the t terms have to be the same. Right? Otherwise, it's not the same polynomial. And then finally, the constant terms have to be the same. So that gives me this has to equal that. This term, the t term, has to equal 0t. The constant term has to be 0 in order for the polynomial on the left to be the same as the polynomial on the right. That's going to give me 3 equations, and I have 3 unknowns. So let's write this equation. 4c2 has to be equal to 2, right? So you can think of this as coming from 4c2t squared is equal to 2t squared. And that has to be true for all t, even t not 0, so you can divide that out and you get exactly this expression. The coefficient on t has to be 0. So the coefficient on t for the left-hand side is 8c2 plus 4c1. Coefficient for t on the right-hand side is 0. And on the left-hand side, the constant term is 2c2 plus 4c1 plus 4c0 has to add up to 0 because it's a 0 constant term on the right. Okay, now this is going to turn out to be relatively straightforward, but it doesn't always come out quite so nice. I have 3 equations, 3 unknowns. I have to solve this system. I can solve for C2, then use that to solve for C1, and then use that for C0. So in this case, the way to do this is relatively straightforward. Other times, this can be a mess. So just be very careful to stop and reset and look at the system of equations without thinking about what's above and ask, how do I deal with this system of equations? So this equation, the first equation, 4c2 equals 2 implies that if I divide both sides by 4, c2 is 2/4, and I'm going to write that as a half. This equation, 8c2 plus 4c1 is 0. I know that c2 is a half, so I have 8 times a half plus 4c1 is 0. 8 times a half is 4, plus 4c1 is 0. Subtract 4 from both sides. Divide 4 by both sides, I get c1 is -1. So let me just highlight C2. So now I have C2, I have C1. And finally, the last equation, 2c2 plus 4c4 plus 4c0 is 0. I know that c2 is a half, so I plug in c2 equals a half. I know that c1 is minus 1, so that becomes 4 times minus 1, and I do not know c0. 2 times a half is 1. 4 times minus 1 is minus 4. Oops, and that is 0. So I get 4c0. If I add 4 and subtract 1, I get 3 on the right-hand side. So c0 is 3/4. So let me rewrite that now. Again, my original differential equation was x double prime plus 4x prime plus 4x equals 2t squared. My homogeneous solution was r1 e to the minus 2t is r2t e to the minus 2t. And my particular solution, I said, was c2t squared plus c1t plus c0. I substituted that back into the original equation and found that c2 is a half, c1 is minus 1, and c0 is 3/4. So my particular solution is 1/2 t squared minus t plus 3/4, which means my solution is the homogeneous plus the particular solutions. So I'm going to have r1 e to the minus 2t plus r2t e to the minus 2t plus 1/2 t squared minus t plus 3/4, which is my solution to my original differential equation. And again, you should be able to take this, plug it back into the original, and check it. I'm not going to do that here for interest of time, but that would be my next step. All right, let's do another example. X double prime plus 4x prime plus 4x equals 2e to the 3t. First step. Solve for the homogeneous equation. Xh double prime plus 4h x prime plus 4xh equals 0. So I took this, placed the right-hand side with 0. This is the exact same thing as the previous example. So I'm just going to use that result and state that my homogeneous solution looks like r1 e to the minus 2t plus r2t e to the minus 2t. Now I can focus on the particular equation, which is xp double prime plus 4x prime plus 4x is e to the 3t. Okay, so now I got to stop and reset. I have an exponential. So I want to know what kind of function, when I take the function, its derivatives, and then add them up, I'm going to get another exponential. In this case, it's e to the 3t. So my guess is going to be, I'm going to think it's going to be some kind of exponential function where it's e to the 3t. Because if I take this and take its derivatives, I just keep getting e to the 3t, and I'll get that. So my guess, so I don't know which one it's going to be, so I'm just going to guess some c times e to the 3t. And if this doesn't work, I'm going to be okay. By the way, in the previous example, I skipped a step. And this is really important in that before I proceed, I should look at this and ask, does this appear in the homogeneous solution? There's no e to the 3t's, so I'm good, and I'm just going to proceed like I did before. So I'm going to take this, I'm going to plug it into my differential equation, and I'm going to ask, what does that imply about c? So I'm going to need the first derivative. It's going to be c times e to the 3t times 3. You need the second derivative. So it's going to be c e to the 3t times 3 times another 3. So I'm going to get a 9. If I plug this in, so xp double prime is 9c e to the 3t plus 4 times x prime, which is going to be 3c e to the 3t plus 4 times c e to the 3t has to equal 2e to the 3t. And now I'm just going to play algebra games, and it's going to be the same idea. On the left-hand side, I should get an e to the 3t, and I basically, if the left-hand side equals 2e to the 3t, then the coefficient on e to the 3t on the left has to equal 2. So let me collect terms, and notice I have e to the 3t, e to the 3t, and e to the 3t. So I can factor out an e to the 3t. I'm going to leave the right-hand side alone, so I've got 9c, 4 times 3 is 12c, and that's going to give me plus 4c. So let's see, 25c e to the 3t equals 2e to the 3t. This has to be true for every t. So that means then that I can factor that out or ignore it. So I get 25c is 2, or c equals 2/25. So my particular solution is 2 divided by 25 times e to the 3t. My homogeneous solution is r1 e to the minus 2t plus r2t e to the minus 2t, which is coming from here. And now my whole solution is going to be the sum of the homogeneous plus particular. So I'm going to get r1 e to the minus 2t plus r2t e to the minus 2t plus my particular, which is 2/25 e to the 3t. Let's do another example. Let's do y double prime plus 4y prime plus 4y is 2 cosine 3t. First thing, homogeneous solution. So my homogeneous solution is the same equation. It's going to come from the same equation, only I'm going to have a 0 instead of whatever nonsense I have on the right-hand side. Again, this is the exact same thing as we saw before. It just says y instead of x. So I'm just going to take advantage of what we did before and say my homogeneous solution is r1 e to the minus 2t plus r2t e to the minus 2t. And now I can focus on the particular solution, which is going to be a solution to the equation. I'm ignoring the homogeneous part for now. Okay, so now I have to stop and reset and think about what do I have. I have a cosine looking thing on the right hand side. And how do I get a cosine? So I'm looking for a function that when I take the function and I take derivatives, I'm going to get a cosine. So you might guess it's something times cosine of 3t, because if I take this thing and start taking derivatives, I'm going to get cosines. But notice the first derivative of this is going to be a sine. And if I take a derivative of a sine, I'm going to get a cosine. So it's possible that my solution has a sine in it. It might not, I don't know, but I have to consider that as a possibility. So for my particular solution, I'm going to include a sine 3t terms. The reason being, if I take this function and I take derivatives, I'm going to keep getting cosine 3t's and sine of 3t's all hanging out, and I want to make this go away. And what I'm thinking is I can think of the right-hand side as 0 times sine of 3t. So when I plug this back in, I'm basically going to get a whole mess of stuff that looks like cosines plus sines. I know the coefficient on the cosine terms has to add up to 2, and the coefficients on the sine terms have to add up to 0. So I'm going to take this, plug it into my equation, and ask what does it imply about C1 and C2. So I need two derivatives. Derivative of cosine is minus sine. Put then I got to multiply by 3 because of the 3t. Derivative of sine is cosine. You have 3t, but the derivative of 3t is 3. And now I need another derivative because I've got two derivatives here. Derivative of sine, so I'm going to have c1 minus c1. Derivative of sine is cosine. But derivative of 3t is 3. So I'm going to have a 3 times 3. Derivative of cosine is minus sine. But derivative of 3t is 3. So I'm going to have that. So I'm going to take that, plug into here. So y double prime, I'm going to have minus 9c1 cosine of 3t, and then minus 9c2 sine of 3t. Now I'm going to have to add 4 times y prime, and just reading that straight off now, this is minus 3c1 sine of 3t plus 3c2 cosine of 3t, and plus 4 times y, 4 times y here. So now using this line, I get c1 cosine 3t plus c2 sine of 3t. That has to all add up to 2 cosine 3t plus 0 sine 3t. All right, let me clean this up. So I'm going to multiply this through, expand it all out, and then start collecting cosine and sine terms with the idea that eventually all the coefficients on cosine have to add up to 2, all the coefficients on sine have to add up to 0. So I'm going to leave the first line alone. So I have minus 9c1 cosine 3t minus 9c2 sine 3t. 4 times minus 3, I'm going to get minus 12c1 sine 3t, plus 4 times 3 is 12c2 cosine 3t. And then multiplying the 4 through, I'm going to have plus 4c1 cosine 3t plus 4c2 sine 3t. All have to add up to 2 cosine 3t plus 0 sine 3t. All right, so I'm just going to add up stuff. So I've got minus 9 c1 cosine 3t. And here I have a plus c2 times 12 cosine 3t. And here I've got to have a plus 4c1. Sorry, that's a mess, but plus 4c1 cosine 3t. Now for my sine terms, I have a minus 9c2 minus 12c1 plus 4c2, and that all has to add up to the right-hand side, which I said is 2 cosine 3t plus 0 sine 3t. So this is a mess. Minus 9c1 plus 4c1 is minus 5c1. I leave the c2 alone. Minus 9, let's do this. I'm going to keep these consistent. So I have a minus 12c1, then a minus 9c2 plus 4c2 is minus 5c2. This has to all equal 2 cosine 3t plus 0 times sine 3t. The only way this term can equal this term is if minus 5c1 plus 12c2 equals 2. And the only way this term can equal this term is if minus 12c1 minus 5c2 is 0. Notice I have two equations, two unknowns. All right, so I'm hoping I can solve this. So let's rewrite that. So my differential equation was y double prime plus 4y prime plus 4y is 2 cosine 3t. My homogeneous solution was r1 e to the minus 2t plus r2t e to the minus 2t. My particular solution was c1 cosine 3t plus c2 sine of 3t. I took that and plugged it into the differential equation, and that implies that minus 5c1 plus 12c2 is 2, and minus 12c1 minus 5c2 is 0. And just like before, at this point, we just have to stop and reset and ask, how can we do this? This one's not going to be so easy. So here's what I'm going to do is I'm going to use this equation to solve for one variable and then plug it into the first equation and solve. So let's see. Yeah, let's solve for C1. So if I add C2 to both sides, I get minus 12C1 is 5C2. And if I divide both sides by minus 12, I get that C1 is minus 512C2. Now I'm going to use the first equation. I have minus 5 times C1 plus 12C2 is 2. But I know that C1 is minus 5/12 C2. So if I multiply this through, I get minus 5 times minus 5. I get 25/12 C2 plus 12 C2 is 2. Great. I'm going to need a common denominator. So I'm going to have 25 over 12 C2. So this is going to be 12 squared over 12 C2. So I'm going to have 25/12 plus 1/44 C2 is 2. So that's going to be, what, 169 twelfths. C2 is 2. So I multiply both sides by 12. I get 24, then divide both sides by 169. So I get that C2 is 24 over 69. And we said C1 is minus 5/12 times C2. That's coming from this equation. So let's see, I'm going to get 24 divided by 12 is 2 times minus 5. I get minus 10 over 169. So that means my particular solution is going to be C1, which is minus 10 over 169 times cosine 3t, it's supposed to be 9, plus C2, which is 24 over 169 times sine of 3t. So my solution is going to be the homogeneous plus the particular. Homogeneous is r1 e to the minus 2t plus r2t e to the minus 2t. And the particular is minus 10 over 169 cosine 3t plus 24 over 169 sine of 3t. All right, and again, so this is my whole solution. I can now use this to figure out, I can use this to get my solution, and I can double check it by just plugging into the original DE. All right. Another example. Let's go with y double prime plus 4y prime plus 4y is 2t squared plus 2e to the 3t. Homogeneous solution. I replace the right-hand side with 0. And again, this is the exact same equation we had before. So my homogeneous solution is going to be the same thing. It's going to be r1 e to the minus 2 times r2 t e to the minus 2t. For my particular solution, something of this form. Okay, this is going to be classic divide and conquer. I've got two things here, and because it's linear, I can think of these separate. I've got a second order polynomial there, and I've got an exponential there. So I'm looking for a function that when I plug it in here and I take its derivatives, I end up with that. So my guess for just that is going to be another second order polynomial. Because if I take a second order polynomial, take its derivatives and add it together, I'm going to get a second order polynomial. So the most general way I could write that is just something times t squared plus something times t plus a constant. For the exponential, I can treat this separately. A function that when I take it and take its derivatives and add them up and I get an exponential, I'm going to guess is another exponential. So let me call that e to the 3t, but I don't know what that's going to be, so let me call that k. And so now what am I going to do is I'm going to basically plug it into here and ask what happens. So if I take the first derivative, I'm going to get 2c2t plus c1, and derivative of c0 is 0, and derivative of ke to the 3t is ke to the 3t times 3. And I need two derivatives because my original equation has two derivatives. So derivative of 2c2t is 2c2, derivative of c1 is 0, derivative of 0 is 0, and derivative of ke to the 3t is ke to the 3t times 3, but I had a 3 carry over from the previous step. If I plug this into my differential equation, I have y double prime is 2c2 plus ke to the 3t plus 4 times y prime. So I'm going to have 2c2t plus c1 plus 4 times ke to the 3t times 3 plus 4 times my y, so I get c2t squared plus c1t plus c0 plus 4 times ke to the 3t. All this has to equal 2t squared plus 2e to the 3t. And it's a bit of a mess, so I'm going to collect terms and ask what does it imply. So for my t squared terms, that's the only c2 t squared terms that shows up anywhere. So I'm going to have 4c2t squared. For my t terms, I'm going to have a t term there and a t term there. So this is going to give me 4 times 2 is 8, c2 plus 4 times c1 times t. And now for my constant terms, I'm going to have a tc2 from there plus 4 times c1. And then here I'm going to have plus 4 times c0. And now for my exponential terms, so just focusing on these, for my e to the 3t, I'm going to have a k. This is going to give me a plus 12k, and this is going to give me a plus 4k. All of this has to equal my original right-hand side, which is 2t squared plus 2e to the 3t. And notice I get exactly the same thing I had before. This coefficient has to equal that. So 4c2 equals 2. The coefficient on t, there's no 0t here. Now, there's no t, but I can think of it as 0t times 0. So 8c2 plus 4c1 has to be 0. And notice for my constant terms, those have to add up to 0. And this is exactly the same thing that happened before. And now for my exponential terms, everything in here has to be equal to 2. So that's 13. Is that what I got before? I just want to make sure. Oops, something's wrong. Oh, that's a 3 squared. So where did I go? Oh, this term right here should be 9, right? There should be a 9 there. Sorry about that. Which means that this should be a 9. So that's 20. That's the 25k equals 2, and that's what I had before. Sorry about that. Okay. Notice this system of equations is exactly the same thing we had before. And before we had C2 was 2. Solving this thing, what did we have before? Was that C1 was, what did we have? -1. And then C0, what did we have? We had that was, sorry, just want to make sure that was 3/4. And then here we get k is 2 over 25. And so now plugging this into our assumption for the particular solution, we get that y is going to be the homogeneous plus the particular. Homogeneous is r e to the minus 2t plus, r1, r2 t e to the minus 2t. And the particular solution is going to be 2t squared minus t plus 3/4 plus 2 over 25 e to the 3t. And what I want to emphasize here is everything we did here is exactly what we've seen in the previous examples. Right? I can think of this as I can divide and conquer, because when I saw the 2t squared plus, what was it, 2e to the 3t, I can focus on that and focus on that and just work from there and just stay consistent and work through.